Students, physics class 12, electric flux and Gauss theorem, video number 2. In this video we read about Gauss theorem and its application. What is Gauss theorem? In video number 1 you read about electric flux, and in electric flux it is said that when any closed surface plays in the electric field, when any closed surface plays in external electric field, then the electric flux pass through them phi is equal to integration of E dot dA. What Gauss theorem is? Gauss theorem said that Gauss theorem is related to the closed surface when it is placed in the external electric field. See that Gauss theorem said that the net electric flux pass through any closed surface. The net electric flux pass through any closed surface. It is denoted by phi integration of E dot dA. That is the net electric flux pass through any closed surface is equal to 1 upon epsilon naught times to the net charge enclosed by the surface. You can write Q upon epsilon naught. This is mathematical form of Gauss theorem. The net electric flux pass through any closed surface is equal to 1 upon epsilon naught times to the net charge enclosed by the surface. That is Gauss theorem, and this is mathematical form. Now proof of Gauss theorem. To prove of Gauss theorem, we suppose this is any closed surface. Suppose this is any closed surface in which any point charge Q is situated at point O. Now, since it is plus Q charge, so electric line of force emit from the closed surface. Electric flux pass through the closed surface. We have to find out the electric flux pass through this closed surface. For this, we have to take any point. We take any point P on the surface and take a small area, any point P on the surface, and take a small area around P. Suppose this surface make solid angle d omega, and the distance of the point P from point O is r, and this small surface dA make angle d omega at point O. Suppose that. Now first we find out the electric flux pass through this closed surface, a small closed surface, and then we integrate them, then the electric flux come through the whole surface. To find out the electric flux pass through this small surface, we see the direction of area vector and electric field. The direction of the electric field is this. Electric field is directly rays emit from closed surface. That is the direction of electric field. Electric field is straightly. You know that the electric line of force emit from charge plus Q charge. So the direction of the electric field is this, and the direction of area vector. Area vector is this. Area vector is perpendicular to the surface. Since this surface is rough, not regular, that is why there is some angle between dA vector and electric field. Suppose this angle is theta. So the electric flux pass through this closed surface, that is d phi E is equal to integration of E dot dA. The electric flux, the magnitude of E is E and dA, and the angle between them is theta, dA cos theta. D phi is equal to dA cos theta. Electric flux pass through the closed surface. This is small surface. This is now the electric flux pass through the whole closed surface, that is denoted by phi is equal to integration of E dot dA. E dot dA. Phi is equal to integration of E dot dA. The value of E dot dA is E dA cos theta. Now putting the value of intensity of electric field, the intensity of electric field at any point due to this charge, this point charge, you know that the value is E is equal to 1 upon 4 pi epsilon naught Q upon r square. So putting the value phi is equal to integration of 1 upon 4 pi epsilon naught Q upon r square into dA cos theta. Up constant are removed from integration. 1 upon 4 pi epsilon naught q of q, that is constant, dA cos theta upon r square. And dA cos theta upon r square is the solid angle subtended by this small area at this surface. Since the line are not perpendicular to the surface, and when the line are not perpendicular to the surface, so the angle subtended by this small area at this point, d omega, not dA upon r square, that is dA cos theta upon r square. That is dA cos theta upon r square. So electric flux, that is d omega d phi e. Phi is equal to 1 upon 4 pi epsilon naught q integration of d omega. D omega is the angle subtended by this small area at this point, at point O, and integration of d omega, it means the solid angle subtended by the whole surface at point O. And we know that the angle subtended by the whole surface at point O, that is 4 pi steradian. In video number 1 you read that. So 1 upon 4 pi epsilon naught q into 4 pi cancel out. Now phi is equal to q upon epsilon naught. This is Gauss theorem. This is the provement of Gauss theorem. Plus q charge is situated in the closed surface, then the electric line of force emit from closed surface. In this condition, the electric flux is positive. Electric flux phi is equal to plus q upon epsilon naught. And when it is negative charge, the electric line of force enter to the closed surface. In this condition, the electric flux is negative. Phi is equal to minus q upon epsilon naught. And when many charges are situated inside the closed surface, then the electric flux pass through the whole closed surface. Phi is equal to sigma q upon epsilon naught. Sigma q means the algebraic sum of all the charge with sign. And when any charge is placed outside of the closed surface, suppose this is any closed surface, and when any charge q is placed outside of the closed surface, then the electric flux pass through the closed surface is 0, because the electric line of force emit from positive charge. In half part, you are seeing in half part the electric line of force are entering, and in half part the electric line of force are exiting. So the net in half part the electric flux is negative, other half part electric flux is positive. So the net electric flux pass through the closed surface is 0. So when any charge is placed outside of the closed surface, the electric flux is 0. That is the provement of Gauss theorem. Now we read the application of Gauss theorem. Application of Gauss theorem is very important. With the help of Gauss theorem, we can find out the intensity of electric field at any point due to any charge object. First application of Gauss theorem is intensity at any point due to point charge. And then intensity at any point due to point charge. In first chapter, you read this, the intensity, you find out the intensity of electric field at any point due to point charge, that is by the definition. But now we find out the intensity of electric field at any point due to point charge by the Gauss theorem. Suppose this is any point charge q is situated at point P, at point O, and we have to find out the intensity of electric field at r distance from it at point P. To find out the intensity of electric field at this point, we draw closed surface. We cover charge. The Gauss theorem is applied for closed surface. That is why we have to draw closed surface. That is called Gaussian surface. Gaussian surface is that surface which is used to find out the intensity of electric field at any point. That is hypothesis surface. So we take O as a center and draw a closed surface passing through point P of radius r. This is a spherical surface. This is a spherical surface. Now plus q charges inside the closed surface and take a small area around T. Same method is applied according to Gauss theorem. Take a small area around P dA and find out the direction of electric field. The direction of electric field is this, and the direction of area vector is also this, because this is a spherical surface. When any line drawn from the center of the surface, it is perpendicular to the surface, and area vector is also perpendicular. So E, dA are parallel to each other. So the electric flux pass through this closed surface. D phi is equal to vector E dot dA. It means E dA cos 0. They are parallel to each other. E dA. This is the electric flux pass through the small surface. Now the electric flux pass through the whole closed surface. Electric flux pass through the whole closed surface. Phi, according to Gauss theorem, integration of E dot dA. Putting the value of E dot dA, phi is equal to integration of E dA. Now we know that the electric flux pass through the closed surface is Q upon epsilon naught. So we put phi is equal to Q upon epsilon naught according to Gauss theorem. Q upon epsilon naught, and E is constant. E is to be find out. Area, integration of dA. dA is the area of this small surface. Integration of dA means whole area of the surface, closed surface, that is 4 pi r square. Integration of dA means A, that is 4 pi r square. Now Q upon epsilon naught, E into 4 pi r square. The value of E is 1 upon 4 pi epsilon naught Q upon r square. This is the intensity of electric field at any point due to point charge. And with the help of it, we can also prove Coulomb's law. When any Coulomb's law, proof of Coulomb's law, when any point charge Q naught is situated, test charge Q naught is situated at this point P. So due to the intensity of electric field, the force act, we know the value of intensity of electric field at this point. And when any charge placed in the electric field, there is a force act on it. F is equal to Q naught E. To proof of Coulomb's law, we place a test charge at this point. So the force act on it, F is equal to Q naught E, and putting the value of E, 1 upon 4 pi epsilon naught Q naught upon r square, that is Coulomb's law. This is first application of Gauss theorem. Okay.